Electrochemistry. So here today I'm going to start a new chapter, electrochemistry. Okay. So electrochemistry is a branch where we study the production of electricity from some spontaneous redox chemical reactions, and also to perform some non-spontaneous chemical reactions with the help of electricity. Okay, so it is a branch where we study the generation of electricity from spontaneous redox reactions and to perform or carry out non-spontaneous chemical reactions with the help of electricity. That is the thing that we are going to study in electrochemistry. Okay. The branch of science which deals with the production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to bring about non-spontaneous chemical reaction is called. Okay, I'll just change reactions and write transformations. Transform is called electrochemistry. Electrochemistry is broadly classified into two categories. Okay. production of chemical change. Non-spontaneous. Chemical change by electrical. Okay, generally we call this one to be phenomenon of electro. And second, conversion of chemical energy into electrical energy. That is generation of electricity by electrical conductors. The substance which allows the passage of electric current substances which are called electrical conductors. And these substances which do not allow the passage of electric current are called insulator. That we know. I need not have written. Types of electrical conductor. That you know it very well. What are those? Metallic conductor. I've already explained in solid state how does it conduct. Second one is electrolytic conductors. The metallic conductors are also known as electronic conductors, and these are known as electrolytes. These are metallic substances which allow the electricity to pass through them. Mind it, there is no change takes place. Without any chemical. So these are metallic conductors. I told you how does it go? Because the valence electron comes out and they surround the metal cations. All right. And when the electron from outside they come, one electron will come, other will go out. So in this case, all the time the number of electrons remains same, so there no chemical change takes place in metallic conduction. Okay. Now, the, the metallic conductance Depends upon. Please remember. These are in a book. Many things which I have read, I will be rating may not be in the book, but thing which is in the book, I'll mention. Depends upon few factors. Few factors. What are those? The nature and structure of the metal. All metals do not show same conductivity of the metal. Second, number of valence electron per atom. Third, the density of the metal. If the density of the metal is very high, conductivity will be less because they will be compact. Electron will not be able to flow. The density of the metal. And fourth, temperature. Please remember, I told you in solid state that electrical conductance by metals decreases with increase of temperature. Electrical conductivity of metals decreases with increase in temperature.
Done, sir.
Then we come to electrolytic conductor or electrolyte. That also you know the definition. You have read in school also. What is this? The substances which can conduct electricity either in molten state or in aqueous solution are called electrolytes or electrolyte. The substances which conduct electricity either in liquid or either in liquid state or in their aqueous solutions are called electrolytic conductors or electrolytes. Please remember one thing. Note these substances undergo chemical decomposition by the passage of electricity. See, for example, sodium chloride. Forget that. Liquid means fused. See, it has become sodium metal. Sodium goes out. That all of you know it. Second, the electrolytic conductivity increases with increasing temperature. It is a chemical change. Please remember, these are the basic difference with metallic conduction and electrolytic conduction. Metallic conduction is physical change, and conductivity decreases with increase in temperature. Electrolytic conduction is a chemical change, and conductivity increases with increase in temperature. I have given you, this is the basic difference if it is being asked in your school exam.
Done, sir.
Okay. Classification of electrolytes. Depending upon the amount of electricity conducted, they can be classified into two categories. Okay. Right now. And in electrolytes, who conducts electricity? It is the ion. Right now. All electrolytes do not ionize to the same extent. On this basis, electrolytes are classified into two categories. Okay. Strong electrolytes and B, weak electrolytes. What is strong electrolyte? The electrolytes which are almost completely dissociated into ions in solution are called, from example, acids say like HCl, H2SO4. They are acids. Then sodium hydroxide, potassium hydroxide, alkalis. Then sodium chloride, potassium chloride, ammonium chloride. Huh? They are all salts, etc. B. These all things we know. Huh? I should not have written also. But still, I feel little insecure if I don't write it, because you people are unique species, special type of Homo sapien. The electrolytes will undergo partial ionization in solution in aqueous solution are called the electrolytes. Okay. Example. CH2CO3 is called carbonic acid. This is acetic acid. Calcium hydroxide, ammonium hydroxide. Okay, bases or alkali. Then say mercury chloride, zinc chloride, zinc bromide, and all sorts, etc. Just like I have seen that I've written down the factors which controls the metallic conductivity. So there are some factors which control the electrolytic conductivity. Just a minute. Huh? What did I keep my pen? Oh, yes. Yeah. Conductivity of electron. See, there is a difference between metallic conductivity and the electrolyte conductivity. So let me show you. That is, you are staying in a rented house. So many people are staying in that. So many families are staying. So it may happen that all of the houses may provide water in your kitchen as well as in your washroom. So this water is coming through the washroom. Okay. So this is your tap. Very poor in drawing. This is the tap. And this is the bucket. So you open the bucket, water. Water is coming. See, when the water comes through the pipe, water moves. Pipe does not move. Okay, so water will fall in your bucket. This is in your washroom or in kitchen. So it is your. But it may happen 2-3 families are there and your tap is outside. So your tap is out. And your tap is outside. How will you bring water? You will bring water. This water will fall, and this is your bucket. You have to carry the bucket to your house. Okay. So now, if you have more number of buckets, you can bring more water. If your buckets are less, then you'll have less amount of water in your house. So electrolytic conductions are like this. Why? In electrolytic conduction, it is the ions which carry the electricity. If the number of ions in the solution is more, conductivity more. And if the number of solution ions are less, then the conductivity is less. Clear? So there's a difference between metallic conductivity. Metallic conductivity, that is the one that electricity that you are using at your home. Electron is flowing through your electrical wires. Electrons are directly coming to the place where you are going to harness it. The electrons flow. You don't have to do anything. Okay, it is flowing through the metallic pipe, so metallic wire, but the wire does not change. It doesn't undergo any chemical change. So the wire, this wire, you can use it. If you are careful, you can use it for 50-60 years. Okay. But in electrolytic conduction, it is the ion which brings the or carry the electrons from one place to another. So what you can write? the conductance of an electrolyte depends upon the number of ions present in the solution. Okay. Now again, the number of ions depends upon the electrolyte also. Strong electrolyte undergoes 100% dissociation, ionization. So in that case, number of ions are more. So in that case, the conductivity will be more. The strong electrolyte undergo complete dissociation, and so have and so produce more ions than produce more ions, and so its conductance is high. On the other hand, weak electrolytes undergo partial dissociation and releases less number of ions, resulting poor conductivity. This is one. But see, you know, a person who is very lean and thin, he can move very fast. But person who is very fatty, or maybe that he is being surrounded by so many friends, in that case, you will find the speed of displacement or movement is less because all the friends are moving together. There should be bigger space for their movement. So it also not only depends upon the ions, it depends also on the sizes. The conductance also depend upon the sizes of their solvated ions. Try to understand what is called solvated. See, cation alone not stable, but in the solution they remain like this. Suppose I have taken here sodium chloride that I'm again going to explain in this one. Before solution, what do you write now here? Na plus aqueous and Cl minus aqueous. Okay. Now suppose that in your class you are very close with one of your classmates, very close. Okay. Maybe some reason you had quarrel and you separated. Then in that case, you also will feel lonely and your friend also feel lonely. So in that case, what you will find? That both of you are having some common friend. So some of the friend may think that you are at a fault. You only have created this problem. So they will go and sit near your friend. Others may feel that is your friend is at fault. So they will come and will stay with you. So similarly, these ions are not stable. So in that case, what will happen? Here you will find these water molecules you need not draw. All water molecules will come and surround. Why? See here, this fellow already has lost electron. So electron deficient species should be stabilized with electron rich. If you have lost your parts, obviously you will not go and take help from your younger brother or sister because she doesn't have money or he doesn't have money. You will go to your elder brother or sister who is working or go to your parents. So see here, these electrons are there, so they are rich. So water molecule is going to surround. In case of chloride, hydrogen is electron deficient, hydrogen is going to surround the chloride. So these are called solvated ions. All right. And as it is being done by water, so it's called hydrated. So depend upon the sizes of the solvated ions. Because if the solvated ion size is very large, the moment will decrease, conductivity will decrease. If they are small, then it will be faster, conductivity will be more. Okay. The electrolytic conduction depends upon the following factors. These are so simple, just like our normal life. Nothing, you don't think that these are all alien subjects. Everything we know. Do not read it like a textbook. If you read it like a textbook, then you will think it's very scary. You think that all these things I know, only the new words are being added. Oh, don't worry. I will again point wise. I'll come and explain to you. Have you finished writing?
Yes, sir.
Okay. I'll explain now. This I've given an introduction. Okay, see here. One, nature of electrode. I already told you that electrical conductance depends upon the number of ions present there. Okay, so the strong electrolyte will have higher conductivity, and the weaker electrolytes will have lesser conductivity. Electrolytic conduction depends upon the number of ions present in the solution. So, from electrolytes, as they undergo complete dissociation into ions, conduct more electricity. While weak electrolytes comparatively produce less number of ions. Conduct less. See, I told you that when the electrolytes undergo ionization, they must be surrounded by some polar molecules. So ionization takes place always in polar solvents. Sodium chloride will dissolve in water. It will not dissolve in ethanol or in benzene. Okay. So more polar the solvent is, more will be the ionization. More ionization, more ions. More ions, more electricity. Okay, will be conduct. So now we'll go for nature of solvent. Electrolytes ionize more in polar solvents. Therefore, greater the polarity of the solvent more will be the more is the ionization and greater is the conductance. Now we come for site. I think many of you have gone to Bada Bazaar. You do? No? Maybe one or two did not go. I don't know that Gitanjali has gone there. Gitanjali, did you go to Bada Bazaar? Hello?
Yes, sir.
Really? Huh? Acha. For what you have gone to Bada Bazaar?
Sir, to buy my books.
Oh, good. Acha. Where you can move faster? In Bada Bazaar or in Hello? Where you can move faster? In Bada
Sir, I
Bazaar or
couldn't hear you.
where you can move
Sir,
walk
Police
faster?
Bazaar.
Police Bazaar. Why?
Sir, it's less crowded.
Yes. Acha, now, suppose you have gone with one of your friend who is double of your size in Bada Bazaar. Who can walk faster? You or your
Sir,
friend?
me.
Yes. So it depends upon the size of the ions produced. Acha, but did you go to Bada Bazaar alone?
Yes, sir.
Huh? You've gone alone. Oh, very good. See, sometimes suppose 3 or 4 of your friends go to Bada Bazaar. In that case, can you walk fast? Huh?
No, sir.
You cannot walk fast. Okay, because you are moving in groups. Okay, now I go for the third one. Because from here, sometimes question comes. Size of the ions produced and solvation. See, the ions produced in the polar solvents, okay, say water, are strongly solvated. I told you that ions are alone not stable, so they are being surrounded by water molecules. Hence, their effective sizes, see now they're not alone. They are being surrounded by solvent molecules will increase. Resulting their lower movement. Okay, I'll write here. Larger the size of solvated ions, lesser will be their speed of movement and lesser will be their conductivity. Spelling मुश्किल. Conductivity. First you write, then I'll explain. Done.
Yes, sir.
Okay. Now see, we'll have a comparative study. Huh? See here, conductivity of molten alkali metal. You know alkali metal? Lithium, sodium, potassium, rubidium, cesium. Metal chlorides. See here we did not add any water. We have melted them. It depends upon their size. So how does the size depends? See here, lithium, then sodium. You know that if you go down the group, size increases. See here. So this is the smallest, this is the largest. So which will move fast? This one is going to move fast. Okay, so conductivity will be what? Conductivity will find lithium chloride will have the highest conductivity, sodium chloride, potassium chloride, rubidium chloride, and cesium. Right. Aqueous solution of alkali metal chlorides. See here. In aqueous solution, they are going to liberate sodium ion, potassium ion, lithium ion, rubidium ion, and cesium ion. Lithium ion is the smallest. Okay. Lithium ion is smallest in size and is greatly solvated. See, try to understand. Say your mother has made something, that in your kitchen which you like to eat. So this is a small size, and she has made a bigger size. So she told, no, you cannot eat. I have made for the guest. So when she gone out of the kitchen, which one will eat? This one or this one? Smaller one or bigger one? Which one? Because you are scared. If she sees you eating, then she will scold you. So which one you are going to eat? Smaller or bigger? What happened? You are so honest or what?
Smaller.
Why? Why you will take the smaller one? Why not the bigger one? Because it is tasty. You are interested. Why you have taken smaller? Why not bigger? Justify.
Because the bigger one is being made for the guest.
Nikun, you are almost like your mother. You cannot cheat anyone in this world. Hey, if you put the smaller in your mouth and close your mouth, your mother will be able to see what is inside your mouth. Don't talk. Don't open your mouth. Your mouth or that also will not be swollen. If you take the big one, you will not be able to close your mouth and she can see. Huh? You wanted to eat. Did you bother for your guest? Huh? When you go and quietly eat, we don't bother for anyone. We only that we are scared of mother, so she should not catch us. So I'll put the small one inside my mouth and keep close my mouth. She will not, if she asks you something, you pretend that you did not hear and leave that space. Huh? Gadda, tum log ko buddhi nahi hai. So you eat this one. So what do you find? The smaller ions are being greatly solvated by the water molecules. So in that case, see here, this is the lithium. Now this lithium is being surrounded by water. People are very honest. In our time, it was not like this. When she will make something at home, will only move around her. Moment she gone, at least 2-3 finish. Dari tunggu. See, look at the size now. This is the biggest size. As you go from sodium, potassium, rubidium, cesium, as the sizes are increasing, solvation decreasing. So in aqueous solution, the solvated lithium has the largest size. So the conductivity is just opposite. That is the one who's asking the question. In the question, draw it. Right now. So right now, in aqueous solution, lithium ion is greatly solvated by water molecules. And so the, I'll write here now, hydrated, because water is there now. So hydrated lithium ion. What should I write now here? I'll write LiH2ON plus attains ion, attains a very large size by which its mobility decreases resulting least conductivity. So what should I write now here? Conductivity. See how I write. LiCl, I'll write here aqueous. NaCl aqueous. KCl aqueous. RBCl aqueous. Forget. Take for your exam. Oh, concentration of the electrolytic. See, if the solution is too much concentrated, see, in electrolytic conduction, cation will go to cathode and anion will go to anode. While they pass side by side, they may attract each other because they are concentrated, more ions are there. So in that case, conductivity is less. But if you pour more water, then in between the ions, which the gap was very less, it will now move away. Attraction decreases, so the conductivity increases. What we write now here? The molar conductance. Why do you write molar? Because we concentration we express as molar solution. Molar conductance of the electrolyte electrolytic solution. Varies with concentration. In general, molar conductivity of the solution increases with decrease in concentration. Means what? Decrease in concentration, ion will become less per unit volume. But can you throw it? You cannot throw it. So how should I decrease the concentration? I will add water. Decrease in concentration or increase in dilution. Temperature. See, ions move. We know anything which they move by their kinetic energy. And kinetic energy is directly proportional to temperature. So when you increase the temperature, kinetic energy of the ions increases, conductivity increases. Electrolytic conduction increases with increasing temperature of the solution. Okay, enough for today.